Hello, one and all present here. This is Amit Kumar Singh. Welcome everyone to my class on integrals. So, here in this class, we'll try to understand the concept of integration. So, guys, we know about differentiation. Now, in this class, we're going to talk about integration. What integration is all about. So, when I talk about the concept of integration, this idea of integration has evolved, probably you can say, around 2000 year before. So that time there was a great mathematician called Archimedes. Yeah, I believe you heard of Archimedes principle, right? In fluid dynamics, you have studied about, right? When we talk about the force called upthrust, so when you're putting any solid object into a fluid, so there's opposite force which will work against the weight which we called as the upthrust. So by that way, we connect Archimedes with that, right? But Archimedes, along with this principle of fluid dynamics, had done a lot of work when it comes to integration. So back on those days, the concept of integration was quite popular, and the mathematicians like Archimedes, Euclid, they did remarkable work in integration. And one of the remarkable work what they did, which we know very well, is that they discuss about this. What is the area of the circle? Okay, this concept, the discussion on this concept was something which was very prominent at that time. Now we know that the area of circle is pi r square, right? So if I talk about what is the circumference of a circle, so if I ask you what is the circumference of the circle, you say 2 pi r. So the question comes, is this the pi what I'm talking about in area of the circle and the pi what I'm talking about in circumference, are they two same thing, or they're two different things? Like, is what is this pi is all about? So we say pi is a constant. How I got to know pi is a constant? So back on those days, we know that when you divide the circumference of the circle with the diameter of the circle, you got some constant. We don't know what was that constant. Maybe let that constant is called as pi. Okay, so the concept, the idea what Archimedes has developed is that if you want to find the area of a given regular polygon or irregular polygon, or you want to find the area of any curve, probably if I want to find the area of maybe I want to find the area of this curve, maybe y equal to 1 by x. I want to find the area of this curve. Okay, so to find the area of this curve, what I can do, if I take a small part of this area. Okay, if I take the small part of this area, so this is your x-axis, right? So the small part of this area, if I get, which we called as dx, okay, let the small part is called as dx, and then probably if I talk about what is this length, this is probably suppose width. What is your length? Your length would be fx, okay, function of x. So probably if I ask you what is the area of this curve, for that you just need to find the area of this small part. What is the area of this small part? Consider this like as a infinitely small rectangle. So the area of this small part, that would be nothing but that would be fx into dx. Okay, and then if you just keep on counting the areas of this infinite figures, small rectangles, infinite small rectangles, if you keep adding them, so probably what you will get something which will give you the area of this curve. Now the question comes, at that time the question comes in your mind, that why you just break it like a rectangle? You could have broken it some other way, no, right? So it's not like that you should always break is like a rectangle. When you talk about circle, if I talk about a circle, if this is a circle, so okay, although this does not look like a circle, so probably 1 minute. So let me try to draw a proper circle. Imagine if I draw a circle like this. Okay, you know the circumference circle is 2 pi r. How we got the circumference circle as 2 pi r? Probably for the time being, just think this you know that the circumference circle is 2 pi r. Now what the mathematician at that time they are telling, that if you want to find the area of the circle, what you do, let break the circle into small part. Okay, let try to break the circle into small part. Okay, maybe 1 2 3 4 5 6 7 8. Let try to break the circle into small part. Okay, then what you do, you take this part together. Maybe I just took this part together. Maybe one part I have taken, the part two. Okay, then I have taken part three. Okay, then I have taken part four. Okay, then I have taken part 5. Okay, then what I have done, I have taken part 6. Okay, then I have taken part 7. Okay, then I have taken part 8. Okay, then I have taken part 1. So, so probably I can say this is 1, 2, 3, 4, 5, 6, 7, 8. So what I've done, I've taken the circle. I just cut this circle in the form of the part of a pizza like this. What is this? This is R, right? And what is this part, guys? This part is nothing but 2 pi r by 8, right? I hope you are getting it right. It is a eighth part of the circumference of the circle. Yes or no? This would be what? This would be pi r by 4. Okay. So if I talk about now, if I take this part like this, okay. Now what is this? Now if you see this, this is one part, two part, three part, four part, and you know that per part is pi r by 4, right? So this is 4 part. So what would the value of this? This is 4 into pi r by 4. So this is nothing but pi r. You're getting me right? This is nothing but pi r. And what is this? This is nothing but like a r. So if you think what is the area of this, so assume this like a rectangle. So although it does not look like a rectangle, assume this like a rectangle. So what is the area of the rectangle? Length into breadth is pi r into r. So you will get something called pi r square. So now the question you will say, sir, but it does not look like rectangle. This wavy part is there, right? Wave. You can see the wavy part here. So now, okay, I made it 8 part. Okay, you made million parts. Okay, let make this million parts. Okay, then if you make it million parts and all, maybe it would be like this. Maybe it would be like this, like this, like this. Okay, then it would be like this, like this, like this, and then make once you made million part, then made it billions part like this. So then maybe it would be like a straight line, something like that. So we are talking about that scenario. So maybe if you take a line and maybe if you cut that by 20 parts, and then if I ask you what is the sum of those 20 parts, doing that would be maybe that difficult. But if I ask you to cut it by billions part and then add them together, so then it would be quite possible that that process would be a little bit easier than cutting into 20 part and then trying to do the sum of that. Maybe if I'm asking you what is 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus 1 by 64, maybe this would be difficult work to do. But if I ask you 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 till infinity, so you know this sum would be equal to 1. You know the GP, sum of infinite terms in GP, A by 1 minus R. This you can do by 2 by n minus 1 by 2 to the power n. So this would be 63 by 64. So so here the idea what we want to propose, which was being already discussed by Archimedes and Euclid, was like when you talk about the area of the region, so it would be easier to break that into smaller part, and more smaller part if you break down, and then if you consolidate those areas together, you can get the area of the bigger part. So the mode advancement in this discovery was discussed by Newton. So back in 17th century, Newton spoken about this. Newton said that do not understand integration as something different. Integration is nothing but it is an anti-derivative of differentiation. So if you talk about inverse of a differentiation, okay, you will get an integration. That is what discussed by Newton. Like if I ask you what is dy dx of sine 2x, so you'll say that is equal to 2 sine 2x. Okay. So what Newton said that you can write this as 1 by 2 of d of dx of sine 2x is equal to sine 2x. Okay, sorry. This dy dx of sine 2x, this would be 2 cos 2x. Okay. So you can write this 1 by 2 of d of dx of sine 2x is equal to cos 2x. Okay. So now this idea you please understand that constant can easily get into and go out of this part. So I can write the same thing as d of dx of Sine 2x by 2 is equal to cos 2x. Okay, now I can write this as d of sine 2x by 2 is equal to cos 2x dx. Now, if I talk about integration, integration is nothing but, so integration of d sine of 2x by 2, this is equal to integration of cos 2x dx. So this and this will get cancelled because integration is the reverse of differentiation. So you can say integration of cos 2x dx is equal to sine 2x by 2 plus c. C is the constant. So here doesn't matter because if you do the differentiation of a constant, you will get a zero, right? So it doesn't matter. Okay, what is the value? Because any value, like you take sine 2x by 2 plus 7. If you do the differentiation of this, you will get cos 2x. Okay, or you take sine 2x by 2 minus 37. If you do the differentiation of this, you'll get cos 2x. So this constant does not matter, right? So here the constant part does not matter to us. Okay, that's why we put C here. That is the idea which was discussed by the Newton. So the Newton said that integration is nothing but it's the inverse of a differentiation. So if you know differentiation, probably getting integration is the next easier thing. Okay, you can get easily the integration part. So here if you see this, so the formulas of integration. So for we here in this class we'll discuss the exercise 7.1 in integration. Now these are the formulas which you should be aware about this. So when it comes to integration, so integration is the inverse of differentiation. So you can see very easily. You have to remember this. For working on the exercise problem, you need to remember these formulas. If you know this formula, solving would be much more easier for us. When we'll work on, we can do it very fast if you know the formulas and all. Okay, like see this. So you know this part very well. Okay, the differentiation dy dx of x to the power n, you know that is nx to the power n minus 1. Okay, so the integration of nx to the power n minus 1 dx, that would be nothing but that would be x to the power n plus 2. So this is the idea what we want to communicate here. So either you understand integration as the inverse of a differentiation or you have to remember the formulas. Okay, so you have, this is very important formula. For the time being, you can buy her x to the power n. Okay, dx that would be equal to x to the power n plus 1 by n plus 1 plus c. Okay, so if I ask you integration of root x dx, very important. So this you can write as integration root x is nothing but x to the power 1 by 2 dx. So this would be 2 by 3 x to the power 3 by 2 plus 1 by 2 plus 1, that would be 3 by 2. So you can remember this. This is important for solving question. This would be important for us. Similarly, if I ask you 1 by root x dx, so this is nothing but x to the power minus 1 by 2 dx. So you apply the same formula, you will get x to the power minus 1 by 2 plus 1. This is 1 by 2. And this would be by 1 by 2. This would be 2 1 by 2 plus c. Or you can write 2 root x plus c. So if you know this, the solving part would be better if you know this. So this is one of the things. The exception here is that the exception is 1 by x dx, integration of 1 by x dx. That would be log modulus of x plus c. This would be your exception. Fine. So the same logic we follow in integration, like you remember, right? d of dx of d of d of dx of e to the power x, you know that that is e to the power x. Similarly, the integration of e to the power x dx, this would be e to the power x plus c. Clear, right? So the same thing we follow, like sin x differentiation is cos x differentiation is minus sin x. So the reverse of this in integration, the integration of cos x dx, that would be sin x, and the integration of sin x dx, that would be minus cos x. Okay, so the same thing here, will follow the same logic here. Okay, so the integration of cos x dx, that would be sin x plus c. Integration of sin x dx, that would be minus cos x plus c. Okay, integration of sec square x dx, that would be 10x plus c, because d of dx of 10x, that would be sec square x. You know this, right? So similarly, the integration of sec square x dx, that would be 10x plus c. Similarly, remember that what start with co, okay, that will give you negative. So when it comes to cos x square x dx, you'll get minus cot x plus c. Okay, sec x 10x dx, that would be sec x plus c. Cosec, it start with co, it will give you negative. Cosec x dx, cosec x cot x dx will give you minus cosec x plus c. Then this might look little bit difficult. So if you remember in the term of differentiation, it would be easier for you. Okay, so instead of remembering this would be easier. So the differentiation of sine inverse x, okay, that would be equal to 1 by root of 1 minus x square. Similarly, the differentiation of cos inverse x, that would be minus sine, okay, minus of 1 by root of 1 minus x square. Similarly, the differentiation of tan inverse x, that would be 1 by 1 plus x square. So the inverse of that you can remember in integration. So that this this looks easier than this. So I prefer that you should remember this than this. So while solving the question, this will become much more easier for us. Similarly, the integration of ax dx, this would be a to the power x by log ea plus c. Okay, so if you know this, then solving the question will not be difficult for you. So like the first question, you have to find the integration of sine 2x. So if I ask you integration of sine 2x dx, the answer will be minus cos 2x by 2 plus c. Okay, so already I explained you this. Okay, while in example I have explained you this. Similarly, the integration of cos 3x dx, that would be sine 3x by 3 plus c. You always add the constant here. The logic of adding constant already I explained you. Okay, then uh, if I talk about e to the power 2x dx, then it would be e to the power 2x by 2 plus c. Same logic you can follow. So just think like as a x, and then you can do it. You will get the answer very easy. Okay, so if I talk about what is the integration of ax plus b whole square dx. So just think like this is the x. What is x square dx? That would be x cubed by 3 plus c. So the same logic here you use. This would be ax plus b whole cubed by 3. And here the constant a is there. So by 3a plus c. Okay. Then the question number 5. Question number 5, if you see, what is the question number 5? This is question number 5. You know the integration of sine x is minus cos x, and e to the power x is e to the power x only. So if I see the question number 5, question number 5, question number 5 is like this: integration of sine 2x minus 4 e to the power 3x dx. So you can write this as integration of sine 2x dx. Okay, then minus 4 e to the power 3x dx. Remember, when you are working on integration, the constant can move in and out of the integration sign, and you can remember as the integration of u plus v dx, that is nothing but integration of u plus the integration of v. Okay, so you can remember this. So here I can write this integration of sine 2x, that this would be minus cos 2x by 2. Okay, this would be, you can bring 4 outside, 4 e to the power 3x dx. So this would be minus cos 2x by 2 minus 4 e to the power 3x by 3 plus c. Clear everyone? Anyone have any doubt? So simple concept, guys. So we have done so far 5 questions. Okay, so in exercise 7.1, we have done so far 5 questions. From question number 6, I will do in next class. So I hope you have understood what all we have discussed in this class. So thank you for listening. Take care. Bye, everyone.